Labeling electrical panels is crucial for safety and convenience. Most people label their panels after completing the installation, and it's a good practice to follow. If the panel is not labeled, it's difficult to identify which breaker controls which circuit, which can be problematic when needing to turn off a specific circuit for maintenance or repairs. To properly label an electrical panel, one can use a voltage detector or a receptacle tester. Here are the steps involved. Firstly, turn off the main breaker. This step is absolutely crucial for safety, as it energizes the entire panel, minimizing the risk of electric shock. Secondly, identify the circuit that you want to label. Make a note of the location of the circuit you want to label, so you will know what to write on the label, for example, living room lights. Thirdly, turn on the voltage detector or receptacle tester. Ensure that it is in the appropriate mode for detecting live circuits. Voltage detectors typically have a setting for detecting AC voltage, and receptacle testers are designed to indicate whether a receptacle is properly wired and energized. Fourthly, test the circuit. Touch the probes of the voltage detector or receptacle tester to the terminals of the circuit breaker you believe corresponds to the circuit you want to label. Be careful not to touch any other metal parts inside the panel. Fifthly, observe the result. If the voltage detector or receptacle tester indicates a live circuit, it means that the circuit breaker you tested is the correct one. A voltage detector will typically beep or light up, while a receptacle tester will show a specific pattern of lights depending on its design. Sixthly, label the circuit breaker. Once you have identified the correct circuit breaker, label it with a piece of tape or a label maker. Write a brief description of the circuit, such as living room lights, kitchen outlets, or HVAC system. Using a circuit tracer is not necessary for this task. A circuit tracer is a more sophisticated tool that sends a signal through the circuit, which can then be detected by a receiver. This can be helpful for tracing circuits in walls or underground, but it's not needed for simply identifying circuits in a panel. After you have labeled all the circuits, turn the main breaker back on. Your electrical panel will now be properly labeled for easy identification and troubleshooting in the future. This process ensures that anyone who needs to work on the electrical system can quickly and easily identify the correct circuit breaker. Here are some additional tips for labeling electrical panels safely and effectively. Firstly, always turn off the main breaker before working inside the panel. This is the most important safety precaution. Secondly, use a voltage detector or receptacle tester to verify that the circuit is energized before touching any wires. This will help prevent electric shock. Thirdly, wear safety glasses and gloves when working inside the panel. This will protect your eyes and hands from electrical hazards. Fourthly, use a label maker or write clearly on the labels. This will make it easier to read the labels in the future. Fifthly, be specific with your labels. Avoid generic labels such as lights or outlets. Instead, label the circuits with specific information, such as living room lights, kitchen refrigerator outlet, or upstairs bathroom GFCI outlet. Sixthly, keep the panel schedule up to date. If you add or change any circuits, be sure to update the panel schedule accordingly. This will ensure that the panel schedule is always accurate and reliable. There are some common mistakes to avoid when labeling electrical panels. Firstly, do not label the circuits without turning off the main breaker. This is extremely dangerous and can lead to electric shock. Secondly, do not touch any wires or components inside the panel without using a voltage detector or receptacle tester to verify that the circuit is de-energized. Thirdly, do not use a metal object to test the circuits. This can create a short circuit and damage the panel. Fourthly, do not label the circuits incorrectly. This can lead to confusion and make it difficult to troubleshoot electrical problems in the future. When labeling an electrical panel, it is beneficial to have a basic understanding of electrical circuits and components. A typical residential electrical panel contains several circuit breakers, each of which protects a specific circuit in the house. The circuit breakers are connected to a bus bar, which is a metal bar that provides power to the circuit breakers. The bus bar is connected to the main breaker, which controls the flow of power to the entire panel. Each circuit breaker is rated for a specific amperage, which is the amount of current that the circuit can safely carry. If the circuit draws more current than the circuit breaker is rated for, the circuit breaker will trip, cutting off the flow of power to the circuit. This helps to prevent overheating and fires. Electrical panels should be inspected periodically to ensure that they are in good condition and that all the circuit breakers are functioning properly. If you notice any signs of damage or wear, such as corrosion or loose wires, you should have the panel inspected by a qualified electrician. It is also important to keep the area around the electrical panel clear of clutter. This will make it easier to access the panel in an emergency. Labeling electrical panels is a simple but important task that can help to ensure the safety and reliability of your electrical system. By following the steps outlined above, you can properly label your electrical panel and make it easier to identify and troubleshoot electrical problems in the future. To reiterate, the process of labeling electrical panels involves several key safety measures and tools. Firstly, the most important step is to turn off the main breaker to de-energize the entire panel. This minimizes the risk of electric shock during the labeling process. Secondly, a voltage detector or receptacle tester is used to verify that the circuits are indeed de-energized before touching any wires. These tools help ensure that no live current is present, adding an extra layer of safety. Thirdly, identifying the circuit you wish to label is crucial. It involves noting the location of the circuit, such as living room lights or kitchen outlets, to ensure accurate labeling. Fourthly, testing the circuit with the voltage detector or receptacle tester is necessary to confirm that the correct circuit breaker is being labeled. The detector will indicate whether the circuit is live, allowing you to match the breaker to the corresponding circuit. Fifthly, labeling the circuit breaker with a clear and specific description, such as living room lights or kitchen refrigerator outlet, is essential for easy identification and troubleshooting in the future. Sixthly, after labeling all circuits, turning the main breaker back on restores power to the panel, and the labeled panel provides a clear and organized reference for any future electrical work. Common mistakes to avoid during this process include skipping the step of turning off the main breaker, which can lead to severe electric shock. Another mistake is touching wires or components without verifying that the circuit is de-energized. Using metal objects to test the circuits can also create short circuits and damage the panel. Incorrectly labeling the circuits can lead to confusion and difficulties in troubleshooting electrical issues later on. When working with electrical panels, it's important to understand basic electrical concepts, such as the function of circuit breakers, bus bars, and amperage ratings. Circuit breakers protect circuits from overcurrents by tripping and cutting off power when the current exceeds the breaker's rating. Bus bars provide power to the circuit breakers, and the main breaker controls the power flow to the entire panel. Periodic inspections of electrical panels are necessary to ensure they are in good condition. Signs of damage, such as corrosion or loose wires, should be addressed by a qualified electrician. Keeping the area around the panel clear of clutter is also essential for easy access in emergencies. In conclusion, labeling electrical panels is a critical task that enhances the safety and reliability of electrical systems. By adhering to safety precautions, using the appropriate tools, and understanding basic electrical concepts, one can effectively label their electrical panel for easier identification and troubleshooting in the future. To further expand on the functionality and components of an electrical panel, consider the role of ground fault circuit interrupters, or GFCIs. GFCIs are specialized circuit breakers designed to protect against electrical shock by detecting imbalances in the current flowing through a circuit. They are commonly used in areas where water is present, such as bathrooms, kitchens, and outdoor outlets. When a GFCI detects a ground fault, which is a leakage of current to ground, it quickly trips the circuit, preventing a potentially lethal shock. In addition to GFCIs, arc fault circuit interrupters, or FSIs, are another type of specialized circuit breaker that can enhance electrical safety. FSIs are designed to detect arc faults, which are dangerous electrical arcs that can occur due to damaged wiring or loose connections. Arc faults can generate high temperatures and are a leading cause of electrical fires. When an FSI detects an arc fault, it quickly trips the circuit, preventing a fire from starting. The proper installation and maintenance of GFCIs and SIs are essential for ensuring electrical safety in homes and buildings. It's important to test these devices regularly to verify that they are functioning correctly. This can be done by pressing the test button on the device and confirming that it trips the circuit. If a GFCI or SI fails to trip when tested, it should be replaced immediately. Furthermore, understanding the different types of wiring used in electrical systems is important for safe and effective electrical work. Common types of wiring include non-metallic sheath cable, or NM cable, which is commonly used for residential wiring, and conduit, which is a protective tubing used to enclose electrical wiring. NM cable typically consists of two or more insulated conductors enclosed in a plastic sheath, while a conduit can be made of metal or plastic and provides a more robust protection for wiring in exposed or harsh environments. When working with electrical wiring, it's important to follow all applicable electrical codes and safety standards. This includes using the correct size and type of wiring for the application, properly grounding all electrical equipment, and making sure that all connections are secure and properly insulated. In addition to labeling the circuit breakers in an electrical panel, it's also a good practice to label any other electrical components such as switches, outlets, and junction boxes. This can help to simplify troubleshooting and maintenance tasks in the future. Labels should be clear, concise, and durable, and should accurately identify the function of each component. Regular maintenance of electrical panels is crucial for ensuring their continued safe and reliable operation. This includes inspecting the panel for any signs of damage or wear, tightening any loose connections, and cleaning any dust or debris that may have accumulated inside the panel. If any problems are detected, they should be addressed promptly by a qualified electrician. Finally, it's important to remember that electrical work can be dangerous and should only be performed by qualified and experienced individuals. If you are not comfortable working with electricity, it's best to hire a licensed electrician to handle any electrical repairs or installations. By following these safety precautions and best practices, you can help to ensure the safety and reliability of your electrical system. It is also important to consider the National Electrical Code, or NEC, which provides comprehensive guidelines for electrical installations and safety. The NEC is updated every 3 years and is widely adopted by states and municipalities across the United States. Familiarizing yourself with the NEC can help you ensure that your electrical work is compliant with the latest safety standards. NEC Table 310.15b16 provides ampacity tables for conductors. These tables specify the maximum allowable current carrying capacity of different types of conductors based on their size, insulation type, and ambient temperature. Using the correct conductor size is crucial for preventing overheating and fires. When selecting circuit breakers for an electrical panel, it's important to choose breakers that are properly rated for the circuits they will be protecting. Circuit breakers are rated in amps, which indicates the amount of current they can safely carry before tripping. The circuit breaker rating should be matched to the ampacity of the conductors in the circuit, as well as the load that the circuit will be serving. Overloading a circuit can cause the circuit breaker to trip, which can be inconvenient and potentially dangerous. To prevent overloading, it's important to distribute the load evenly across multiple circuits and to avoid plugging too many appliances or devices into a single circuit. When adding new circuits to an electrical panel, it's important to ensure that the panel has sufficient capacity to handle the additional load. Electrical panels are rated for a maximum amperage, which indicates the total amount of current that the panel can safely supply. If the panel is already close to its maximum capacity, it may be necessary to upgrade to a larger panel to accommodate the new circuits. It is important to understand voltage drop, which is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause appliances and devices to function improperly or even be damaged. To minimize voltage drop, it's important to use the correct size conductors and to keep the length of the circuits as short as possible. When installing electrical outlets, it's important to use tamper-resistant outlets, especially in areas where children are present. Tamper-resistant outlets have a built-in mechanism that prevents objects from being inserted into the slots, reducing the risk of electric shock. It is good practice to use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can be plugged into electrical outlets or installed to the electrical panel to provide whole-house surge protection. When working with electrical panels, it's important to be aware of the potential hazards of arc flash. Arc flash is a dangerous electrical explosion that can occur when a high-voltage arc is created between conductors. Arc flash can cause severe burns, blindness, and even death. To protect against arc flash, it's important to wear appropriate personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields. Remember that all electrical work should be performed in accordance with applicable electrical codes and safety standards, and should only be performed by qualified and experienced individuals.